About earned value analysis before. We talked about earned value analysis before, and today we're going to talk about a solved example to show how to solve the problem about earned value analysis. So here's a very simple problem. We have a project that consists of 6 activities. We have the duration for each activity in the next column, and this duration, it appears in weeks. And then we have the precedence, the IPAs for each activity. So activity A has no predecessors, B has no predecessors, C has A as a predecessor, and so on. And then we are given the budgeted cost per week. This comes from the estimate. So the cost for activity A is $230 per week. The total duration is 3 weeks. B, $280 per week, and so on. So what we need to calculate is at the end of week 9, this is when we're performing our update or our review of the progress of the project. At the end of week 9, the actual project status was as follows. Activity A was 100% complete, so this is the percent of complete work or work done to date. B was 100% complete, C 75%, D 0, E 60%, and F 50%. And now we are also given the actual cost, how much it did actually cost to finish such activities. So A was complete at the cost of $1,240, B was complete at the cost of $1,500, and so on. The question is, what's the status of the project at the end of week 9? Are we on time? Are we ahead of schedule, behind schedule? Are we on budget? Are we above or below budget? And for each activity, we're going to assume a linear relationship between cost and schedule, and that the BCWS is determined from the earliest start dates. This means that the cost of the activity, the total cost of activity A, for example, is going to be 3 weeks times $430 per week, so it's going to be $690, and that's distributed evenly. So each week we're going to spend the same amount. So let's proceed to solve this problem in a very systematic, organized way. We're going to do it in incremental steps, one step building on the previous one and leading to the next one. Let's start looking at step number 1. So here's what we need to do. We need to draw a cumulative cost curve for this project showing duration and cost, identify the actual cost for work performed, ACWP or AC, BCWS, the budgeted cost for work scheduled, or PV, the planned value, BCWP, the budgeted cost for work performed or earned value, and CV, the cost variance, and SV, the scheduled variance. And we need to determine the values of the CPR, also known as CPI, cost performance ratio or cost performance index, and the SPR, also known as SPI, scheduled performance ratio or scheduled performance index. And finally, after we conduct this analysis, from the numbers that we're going to get, we need to judge whether the project is, how is it performing, above, below budget, ahead, behind schedule, and so on. So the step number 1 is a very simple step. We're going to calculate the total budget for each activity, and that's basically conducted by multiplying the cost per week times the duration of the activity. So it's very simple. Here, for example, 690 is 230 times 3, 2700 is 450 times 6, and so on. When we add these values, this is the total budget, or this is the budgeted cost. It can also be known as BC or budgeted cost. When you add these numbers, it's going to give you here at the end 11,970. What is this number? This number represents the last point on the cash out curve, which is the smooth S curve. What did we call this point before? It was called BAC, or budget at completion. Now, for the solution of this problem, we are not going to use this number because this represents the total cost we expect to spend by the end of the project. But we are not right now interested in the total cost of the project. We are just interested in how are we doing by the end of week 9. So although we added these numbers to get this value here, we are not going to use it. So remember never to use this number because we do not really need it. So step number 1 is to get BC, or the budgeted cost, also known as total budget. Step number 2, again, is a very simple step. We have all the ingredients of calculating the actual cost, or actual cost for work performed. We are given the actual cost, which is basically what we collect from the site and from the invoices and from the receipts and so on. So it's easy to calculate that number, and we are given these numbers. So but just by adding these values, we are going to get the total actual cost. Now this is by the end of week 9. This is not at the end of the project because these were collected at the end of week 9. So this is the AC or ACWP by the end of week 9, and that's the first of 3 numbers that we're going to need. Remember, to solve this problem, we're going to need initially the main ingredients are going to be the AC or ACWP, the BCWP or earned value, and the BCWS or planned value. These are the 3 numbers that can be manipulated to reach the variances and the indices and get all the analysis done. So step number 2, just add the numbers to calculate the AC or actual cost for work performed. Step number 3, we need to calculate now the earned value. The earned value or BCWP. What are the 2 ingredients of BCWP? It's BC, budgeted cost, and WP, work performed. Do we have these 2 ingredients? Yes, we do. In the first step, we calculated BC or the budgeted cost, and work performed or WP was already given to us at the end of week 9, which is this column here, the percent complete. Percent complete represents the work performed by the end of week 9. So all we need to do now is basically multiply these 2 columns. So we're going to take the budgeted cost, total budget, times the work performed for each activity, and that's going to give us the earned value or budgeted cost for work performed. So for activity A, 690 times 100%, B, 1680 times 100%, C, 2700 times 75%, and that gives 2025, D, 2880 times 0%, that gives 0, and so on. So by adding these numbers, now we get 6717, which is the budgeted cost for work performed by the end of week 9. So far we calculated budgeted cost, we calculated actual cost, and we calculated the earned value or budgeted cost for work performed. As you can see here, we have an empty column for BCWS or the planned value. This is something that we have not calculated yet, and we need to calculate in order to reach the 3 ingredients that are going to be used to solve this problem. But from the initial look here, just looking at these numbers, we have here earned value, BCWP, and we have here ACWP or actual cost. What do you think about these 2 numbers? What do they say? It shows initially so far that the actual cost for work performed exceeds the budgeted cost for work performed for the same amount of work, which is work performed, which can be removed, set aside. Now we have actual cost versus budgeted cost. It seems apparent here that the actual cost is greater than the budgeted cost. So it seems that this project, at least when it comes to cost, is over budget. But how is it doing schedule-wise? We are still going to find that in a couple of minutes. So this is the end of step number 3. Step number 4, we're going to draw that network. So we are given activities, as we have here in this slide. We are given the durations, we're given the precedence. So what we're going to do is we're going to draw this network, and then we're going to draw a vertical line at the end of week 9 and measure by the end of week 9 what amount of work should have been complete. So what should have been scheduled by the end of week 9. So we're going to find that activity A starts on week 0, ends on week 3, B starts on 0, ends on 6, C follows A, D follows C, E and F, both of them follow B. So this is basically the durations that were given. We just plotted them on a time and activity axis, which is a regular Gantt chart. And then we drew a vertical line at the end of week 9. So the cutoff date is the end of week 9. And it shows here that activity B has not started yet. Activity E has 3 weeks already expired from a total duration of 6 weeks. So it should have been 50% complete. Activity F has already should have been completed by the end of week 9. So it shows here that the percent complete for activities A and B should have been 100%. For activity C, it should also be 100%. For activity D, 0% has not started yet. Activity E should be 50%, 3 weeks out of 6, and activity F should be 100% complete. So we're going to take these percentages. These represent the percentages of work scheduled. We already had the work performed. Now we have the work scheduled. Think about it for a second now. What do we have? We have the budgeted cost from the very first step. We calculated the earned value. We calculated the actual cost. And now we have the amount or the percentage of work scheduled. If we multiply that work scheduled times the budgeted cost, what do we get? We get the budgeted cost for work scheduled, or what we call the planned value. So this is basically what that slide tells us, that at the end of week 9, activities A, B, C, and F should be 100% complete, E should be 50% done, and D should be 0% complete. So we're going to take these values, we're going to put them in a table like this, and then now we need to calculate the budgeted cost for work scheduled, or PV, and that's going to be basically multiplying the total budget times the percentages that we have in this table, and that's going to give us the budgeted cost for work scheduled, or planned value. Now again, looking at these numbers, the planned value 7530. By the end of week 9 it should have been 7530. The earned value is 6717. So budgeted cost for work scheduled at the end of week 9, 7530. Budgeted cost for work performed at the end of week 9, 6717. Remove the common term, which is in this case budgeted cost. We end up with work scheduled versus work performed. It seems that the work scheduled is greater than the work performed, which means the work performed is less than the work scheduled, which means we are behind schedule. So from the first comparison here, we concluded that we are above budget. From the second comparison, it shows that we are behind schedule. So basically this is the double whammy, bad on cost and bad on time as well. This shows the numbers that we have, that we were given, BCWS, that's our S curve, and it shows here the weekly expenditures. And now we need to start calculating the variances and the indices from the numbers. The scheduled variance is equal to earned value minus planned value. The earned value is 6717, the planned value is 7530, so we have a negative 813 variance. Negative number means that we are behind schedule by an amount of work worth $813, as the earned value is the earned value is less than the planned value. The cost variance equals earned value minus actual cost. So 6717 minus 8205. So here again we have a negative value, which is bad. Negative number means that we are over budget by 1488, as the earned value is less than the actual cost. Now notice that we have a typo here. This should be less than, not greater than. So this number that's the cost variance. The accounting variance is equal to actual cost minus planned value, and again this number does not have any significance whatsoever, as it compares apples and oranges. The SPI or SPR is earned value divided by planned value. We have here a number that's less than 1, which again is bad, so indicates that we are 11.8%, which is the difference between 1 and 0.892, 11.8% behind schedule. The cost performance ratio or index, earned value divided by actual cost, again it's less than 1, 0.818, which indicates that we are 18.2% over budget. So this is basically the summary of how this project is performing. It's not doing very well currently. We can reflect all of this information in a graphical way. So again, this is the curve that we had drawn before, and it shows the final number here at the BAC. And now we drew a vertical line at the end of week 9, and it shows that the earned value is below the other 2 points, the planned value and the actual cost. Remember, just by looking at this curve, if the earned value is the highest point, that would be great. It would be good and good. If the earned value is the lowest point, it would be bad and bad. If it's in between, so if, for example, it's below the AC and above the PV, it means that we are bad on cost but good on schedule. And if they reverse their order, if the PV is the highest one, the EV is in the middle, and the actual cost is at the bottom, it means that we're doing well on cost but we're not doing very well on schedule. But in this case, unfortunately, it's a bad, since the EV is the lowest point. That's basically the answer to that earned value problem. I hope you do understand now how to solve this problem.